Good afternoon, everyone. I'm Brian Horn. I'm with WISP TRACON. We are training and consulting company based both in California and in Latvia, in Riga. Some of you may have met my partner on training sessions in the past, Anders Ahrens. So we're the two behind that. I also own and run Winters Broadband in California. It's a WISP. It's been in business now for 13 years. We've got just over 600 customers. Just a question by show of hands. I had a question is that, how many of you are WISPs or ISPs? Good. And how many of you have written or scripts in the past? A few. Oh, quite a few. Okay, so I'm going to get into a little more detail, and thanks to Javon for all the information he gave earlier. But we're going to take a look at scripting. It really provides us with a method to automate tasks. Ones that we can either do from a run command, and this is where it's something where you've bought a script, say for example a firewall script that you want to apply, or you've got a standard one you want to apply to multiple routers. Or it can be one that you run on a trigger event. And there are a number of ways that you can do that inside of MikroTik. There's, there's the system scheduler, which is at the Pacific time or Pacific interval. Traffic monitor, when traffic crosses a threshold that you've put in there. And then, of course, NetWatch, which is based on ICMP pings that are being sent out and decide as to when the script should run. And you have there the option of running a script when the goes up or down. One of the things that one can do with scripts is basic configuration. We've got over 400 routers out there that we manage for customers. I'm trying to step back. I think he's turning it up. Okay. What happens there is that the admin person actually configures the routers. What they do is they do the software upgrade. They check that the firmware is at the right revision. They run a script. And the only thing you have to do then with these goal configs is about 5 parameters you configure. So you know the router's all going out and they're easily tested. The other way is feature addition, where it's queues that you're adding, where you're taking information out of some other application, or it's, for example, firewall rules. Now, there's, with regard to creating a script, you can configure the router, test the configuration, and then export it. And you don't have to export compact. Export compact is standard and from version 6 onwards, so it is compact by default. But that gives you a script file that you can then apply to any other router. If you're starting from scratch and applying a router, you can either import it, the file in, but the best way to do it is to, if you're producing multiple routers for different applications, is go in, do a system reset with no defaults, and then run off the reset, and you select the configuration file. System comes up, it's clean, it's rebooted, and you've got something in a known state. Scripting examples, what you can use it for, is site power monitoring, and I'll take a lot more detailed look at this for you and show you how one would build a script. So if you've got a redundant power solution, and you want to know what your status is, where do I stand, we'll show you that. Backbone link utilization, you can do scripts for that. And one thing with this is there are a lot of scripts on the wiki out there that you can find. And I'm going to show you a bit of detail on how to debug scripts and how to write them, which will make a lot more sense when you look at some of the ones if you're trying to take them off the wiki and you modify them for yourself. You can do utilization reports. This is where, for example, say you want to collect monthly utilization data from your customers, how much data they used, reset the counters. A little more complicated, and I'll show you a little bit on that as well. And then, of course, you can do automatic backups and then transfer the files back to a central server. One thing with regard to transferring results, there's no sense in keeping it on the router because backups, for example, you want so you can use in events of emergency. So move them back to some central location where they're processing the data that you've collected or you're storing it in case of emergencies. Remember the difference between backup and exports. The backup files are intended for use on the same router. They're not intended for use on another router. There are parameters that are carried in there that will change the router, MAC addresses and things. So if you have, say, a 750 UP out there and you've exported the config, you can put that config onto any other 750 UP and it'll configure it. The only thing you'll have to redo is redo the passwords. You've got various methods of getting the data back: email, FTP, or SSH. And as Javon also said, there's the fetch tool you can use. Email is a very useful one for getting alerts. And you can either use it to send alerts, and you could also use it to transfer files back. If you're using Gmail, you can configure the client on how it's going to connect to the server. So you use the email tool, the server address you're sending it to, the port, which are 587s, which Google uses, your username, who it's from, the username and password, and they use TLS, so you have to set that. Once you've set that in a script and it's set there, you can then go send messages with or without attachments. And it's simple then, it's just send to, what's the address you want to send it to, the subject, that's the top line on your email that comes in, the body, what you want to put in the body, and then if you want to attach a file, you just attach a file. And it's going to go back to your central email system for you. And we'll look at applying some of this. When it comes to writing or testing scripts, as Javon said, one of the problems is debugging. So it's, you have to use slightly different thought process there. So if you're using the terminal, what you can use with terminal is, in Winbox, of course, you can open up multiple windows. So open up the log. So yeah, if we go :log info, and then we issue a command, so inside of the square parentheses, system router board get the model, what it prints for you is just what it got back. So if you're debugging this way, sorry, the same way as if you go get the serial number, it'll bring it back and give you the information. So those lines you can use to, if you're writing a script, to find what the variables are. What do I have to issue to be able to get the serial number, or what do I have to issue to be able to get the parameters from a particular interface? The other way you can do it is you can do it from terminal, in which case you use the put command. So it's put, then with parentheses, we put the command in it, and it'll come back and do exactly the same things that we did up there. So there are the two ways of writing the script. And one thing with the script is, write it in steps, debug it in steps. You try writing the whole lot at once, and you hit a bug somewhere, and it just stops, and then you have the problem finding out where. And I'll show you a bit on that as we move forward. So getting system data, some of it's rather easy to get. So we can go set a variable. Now, there are two types of variable. Global, it's there all the time once it's initialized in the system. Local's only there while the script runs. When the script stops running, anything that's local is gone. So we've said here, global, system identity, we've called it, that's the name we've given the variable, and we've told it to go get the system identity, get name, and put it into system identity. If we want to use it then, we can just go put system identity. It gives us the system identity. And this is the commands that you have to go through to figure out what you want to get back. So that's really simple. If we want to get something like the date, we can go get system date, system clock get date, and we can put into a variable name called system date. If we've made these global variables, anything we now use when we run the script, or when we run the script again or again, it'll be there. So you may want to each time go back and get the date or the clock, because it will have changed each time it runs. If you want to extract the month, the day of the month from the date that you got, then use a pick command. And I've got a quick reference guide I'll give you at the end that you can take away on some of this as well. But yeah, what we're doing is we're saying, look inside this data that we got, so that's the command, which we know got the date back, and then pick out the data that starts in column 4, 5, and 6. And what we get back is we put that into today, and now we got today's date. So in that way, I just use a simple illustration here, but you can use this to get information out of fields where you need it. So data can get complicated. Let's assume we want to get back data that we've got simple queues running on our system where we're controlling the bandwidth to customers. We'd like to know how much each one's used, how much data in the month. So on the midnight on the 30th or 31st, or 1 minute past midnight on the 1st, we want to go and collect the data and then reset the counters. Well, it gets a little more complicated here. So if we went out and we issued a command and we said queue simple, so we moved to that directory, and we say, for example, for I equals 1 to, for I, so we're going to repeat it from lines 141 to 144. We're going to go global bytes, $I, blah, 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 blah. What we're going to end up doing is we'll bring back, we're going to go get the name from each of these fields, that there, and we're going to go pull back the bytes. But one thing you notice that MikroTik did something interesting inside it. There's no way of pulling back the bytes that we want. What it pulls back is it pulls back a string, and it's pulling back the upload / the download. So now if you wanted to do this, you've got a nice complicated situation of trying to figure out the code. So I'll show you how you go about it. So we want to extract the total upload and download bytes. So let's go to simple, queue simple, and we're in that directory and we say global bytes, so it's global variable bytes, and we go get what's in field 141. So I'm not doing the loop at the moment, I'm just getting one of them. And then what I do is say put bytes. So what this is going to do is going to print out what I got back from field 141, and it comes back with that. So I've got the data. Now I know I've got that bit of the command correct. Now if I go and look at bytes, which is this data that I got back, and I say find the slash in it and start a position 0 in the string, that's what find does, it comes back and it tells me that that slash is in position 9. So now I know a bit of information. I know where the slash is. Then what I can go do is I can go say pick out of bytes, the data I got earlier, from 0 to 9. I'll see if 9's correct, and yep, I put that in, and what it brings back is the first part of the string for me. Move on, and I go, and let's go look at what the length of that string is. So I go, find me the length of bytes, and it comes back and it tells me that's 20 characters long. Now I want to get out this last bit of data. I go pick out of bytes, which I got back there, start at position 10, one more than where the slash was, through to the length, 20, and I've got the other bit of data out. So that's how you go through it step by step to build up what you want. That's not how the code will look if you go into the wiki or somewhere else, because programmers make it like making it look really complex, and for consultants, then you have to come back and you pay the consultants over and over because it's hard to figure out what it does. But if you were writing that now, after you've got the information you want, so we'll put all those lines together and we'll write them as 2 lines. We're going to put something else. We're going to go, we've already got we're going to pick out of bytes, starting in 0, find bytes / 0. So it's going to, we've substituted the other pieces we found each time and put them in here, and it comes back with the data. So you can combine those up, so you just substitute, like here we were looking at 20 being the length. If we put it inside square parentheses length bytes, that's the equivalent of what 20 was. So if the string varied, and it will, because depending on how much data is there that you've pulled back from that particular customer, it's going to vary. So that's how you'd go through and do it. So it's like how you eat an elephant, 1 bite at a time. So don't try and do the big picture first, because And debugging this, if you try writing a line like that and debugging it, it might just stop and you get 0 as a response. Go through step by step and then just put it together and you'll find it'll work a lot easier. So I'm going to show you an example of an application, and this is real world, on what you can use. If you've got a remote site, for example, and say you've got 2 backbone links coming into it, you've got access point there, an Omni on it, you must have got 3 radios, you're pulling 8 watts a radio. So if you take a 750 UP and you connect the 3 radios on there, the one thing you now have is your power control. You can turn those off, those radios on or off, or reboot them remotely. You don't have to go there if something goes wrong. If you can attach a 26 amp hour battery or 2 small batteries, whoops, sorry, it's me 1, Thomas 5. I got to avoid that. So if the power goes out, this site will run for about 26 hours on those batteries. If you go buy a Meanwell power supply, this AD155B, it's got a power supply and a charger built in it. Nominally, the power supply gives out 27.6 volts, and the battery charger side of it gives out 27.1, which is what it's feeding here. Put 2 Schottky diodes in there, and you've got a solution. In the event this power goes out, battery power, this becomes higher than what's there, it runs off that. And you now have a solution, a very cost-effective solution without some UPS that's bulky, and this you can fit in any enclosure anywhere. So now if we want to manage that, let's try looking at how we can do that with scripts. Well, the first thing we want to know is what the power on and off voltage is. So all we have to do is go log info system health, get voltage. That's how we get the voltage. If we measure it with the power on, we get 262. Divide by 10, 26.2 volts. That's how MikroTik puts it up. Unplug the power. The unit switches over to the backup power. The batteries weren't charged when this was done. It's 20.1 volts. It's still running the system. I just run the command again, and I get the information there. Now, let's say, okay, we're going to choose a threshold to determine when we're on utility power or not. Let's choose 26 volts as the threshold. A fully charged battery is 25.6 volts. Now, you can tell me it'll be higher, but it's only going to be higher for a very short period of time as it drops down that initial curve. A fully charged is 25.6. It will drop down fairly rapidly to 24 volts, and it will stay there for its period until it starts dropping off after that. So we now have some numbers to work on there. So let's go write the software for the application you want. Now, the best way to do it, and I recommend this, and I come from engineering background plus software at one stage in that, is write what's called pseudocode. So what we want to do is measure the system voltage, which we'll call V system. If we're running on utility power, in other words, V system is greater than or equal 26 volts, we're going to do nothing because we're happy. So else, so if it's not that, it's else. Now we're running on battery power. So let's send an email to alert the power status, and let's include the current voltage in the email we're going to send. So there you got your first part of your project. That's what you want to do. So now we want to send that report back. What information do we need to add for the reporting? So the green line is what we add. So let's go get the system information, the identity of the router, so we know which site it is, the date and the time, because we really want to know what time this happened. And this is one thing, if you haven't done it on your MikroTik routers, set the identity, set the SNTP, and get the real time in the systems, because you want that back for this sort of thing. So we're going to add that information in. Well, we now know when it goes down. So, do we want an alert when the utility power is restored? Because it may be down for a few minutes, it might be an outage, just a short outage. So what we do here is first thing we do is we'll set a global variable called vFlag, and we'll set it to 1 being on. What happens with the global variable, remember, it's there even when this program stops running. So next time the program runs, we have a scheduler set there, and we'll set it to run, say, every 15 minutes or half hour, whatever you want. The next time it runs, it knows what VFlag was the last time it ran. So when we go down here, when we running on battery power, we put in here that we clear the flag. We set it to 0. So now when our power goes out, we set it to 0. If we come in now and we see the power's back on, so the power was out, it's now come back on, and we run the script again, we see the power's back on, we're greater than 26 volts. So if the flag is not set, this was the first time that it ran, the very, very first time that ever the script runs, you'd have to set the flag to 0. Otherwise, what we would do is we send an email alert to say that the power's back up. So now you know you're back in business, and you set the flag to 1, the power's back on. That first line was just there to handle that very first time the script ever ran. So now when it goes down, you clear the flag, you send a message, and every time you go around, it's going to send you that message again, unless you put some code in there to only send it once. But then when the power comes back on, it'll run this, and then clear the flag, and it will just stay in that mode after that. The next bit is, so what happens if the batteries get discharged too low? So it's now the outage is carrying on for a long period of time. You'd like to know that you're now getting in trouble. So if the battery power is less than 25% of charge, which would be equal to the voltage dropping or just starting to drop below 24 volts, you can send an email alert. So at this point, you know, I'm in trouble now. I need to take a generator there, or I need to do something about it. Now, one of the things you could do about it is you could have a backup link. You could have radios and equipment there that you don't necessarily need at that point. So you could power down low priority devices, send an email setting the status, and set a flag saying that you've gone and we created a P flag, which says that we've powered something down. So you can actually load shed to keep it going longer by dropping the power you're using to your backup link. We add in the flag here, so if the power's come back and we see the flag was set, then what we do is we go power up the devices and we clear the flag. So you now have actually written the code that you want to make your application. And this works real world, worldwide. There's the actual script. So you take the script you've got there, and you now go replace those lines and put them in. So we set our flags. If it's run for the first time, we set the flags to what we want them to be. We go get the location data, and notice these are local variables, so we get them each time it runs. These were global variables. They stay there, so it remembers from each time it runs a script. This it picks up each time. We go out and we get the system voltage, and we've created a pointer. This is just something to keep track of account. We configure our email server so that we can send email any time we want. We don't have to put that info in. And this, of course, will all be available to you as part of the slides that MikroTik will make available afterwards. And so here's our script. So one thing with scripts is a hash means it's a comment. And it's just a good idea to put comments there so you know what it is. So this is the main script. And this is where if the voltage is greater than or equal to 26 volts, we do, and the curly bracket is closed down here. There's a start and end. If you tab in and you keep track of where the curly starts and ends, you'll find it a lot easier to, so this piece of code, this if loop is that. This if loop is that. So what we have here is what we're telling it to do if the power's on. If the voltage flag was off, there was a power outage on the last run. We can send an email to advise that power's been restored. And when we go down to here, and we also log it, so we put it in the log as well, because if it's a log item here, and we set the flag so the power's back on. We powered down some devices, and we decided the devices we could power down were devices 2 and 3. So this is where the loop pointer came in. So for devices 2 and 3 that were powered down, we can power them back up. So just interface, PoE, set that interface, PoE auto on, and you turn the power back on. So if you can determine the variable, you can get scripting to do anything for you. And that else if is continued on the next slide. So, oops, sorry, go back one. If anybody tells me this won't work, you're completely correct, it won't work. One of the things you can't do is it's really good to indent like this, the code. You cannot indent a comment. You'll find you end up with some funny error come up. There's no white space before the hash. So if correctly written, that would look like that. The hashes are all in column 1. The other part of the else loop, which is if the power was down, is that. So now we're on battery power, the comment's there. If the voltage is greater than 24 volts, we do this. Otherwise, we do that bit. We're going to say that send an email to let know that the battery power we're running on battery power. So it's going to send information going to say is alert. This is your body in the email. Yeah, sorry, let's start on that. The subject on the email would be low battery voltage. It will tell you the location, tell you the date and the time. And then the body of the message would tell you alert, the location, the voltage is, and this here is picking up the first 2 digits of the voltage, putting a period between them, putting another digit for you, putting a space, and then putting a V. So it will look like 24.8 volts when you read it. So that's all that's doing, is putting together a string of variables so that it reads sense for you in the email when you see it. And then we log it as well, the same way, low battery voltage, the location that is, so it's in your log for you. The same way around here, if the battery charge is less than 25%, then we can power down some devices. And here it's just PoE, and we're doing PoE off, so we can power down. If we got to that, if it's just a case of the voltage is getting low, we've got the messages in there. So you just build it step by step. So when you build, you look at building scripts, use pseudocode. It gets your thoughts in place, and you can figure out what you want to do. If this happens, what I want it to do. You can then get to the code. Use meaningful variable names. If you write it, or somebody writes it for you, or somebody on your staff writes it, they may not be there tomorrow or 6 months later. You may not remember what that cryptic command thing that you put in was. Comment the code. It's really useful when you want to go back later and update it. Use tabs to show where the loops are, so you can see where the actual loop is. Because you can see where the else, this was the do. So if the voltage was greater than 26 volts, do that. It ended there. Then the else started there, and the else ends there. So then you can see where each of the loops are. Test the code in sections. It's much easier to debug, because if you write the whole lot at once, you have a big problem sorting it out. And just remember that with you can always use the get command. One thing, if you write this code, you've got this case of what happens if the voltage is this or this or this. How do I test it? If you just go back to the beginning, and you've got this bit where you get the system voltage, local system, you get the voltage. If you go set this, just comment that one out, and leave it there. You can actually leave it there. Put a line in below. Just say set vSystem equal vSystem and put a voltage. So you can make like 23.8, run the script, and you'll see exactly what it'll do when it's 23.8. Go back, just change what the voltage is there. You don't actually have to change it in the router then, try and vary the voltage in the router, which is really hard to do. You can just run it and test it under different scenarios, make sure you're getting all the messages you want. 2 cautions with scripts. Be very careful with netwatch and reboots. If you decide that you're a wireless ISP and you've got a remote site and you're going to do netwatch, and in the event that the radio is locked up, you're going to reboot, just put sufficient time and a delay in there that you allow the link to come back up. Otherwise, what you do is you end up with it getting into a cycle, and it'll come up. We had one poor ISP in Canada had got into trouble a few months ago and called us, and they'd done that, and the system would come up for 14 seconds at a time, and that was all it was. It was online for 14 seconds, it was off. We managed to recover it from, he wasn't wanting to get out there in winter and replace the radios because he was having a problem. The other thing is, be very careful when disabling or powering down interfaces. You might just power down the one that cuts your connection off. If it's a remote site, so yeah, just be careful on that. Okay. So what I've got for you is, I should have enough for everybody yet. I got a quick reference card, which has got some of the scripting commands on it. And it's also got a subnetting cheat sheet on it there. And we're going to be doing some scripting training in Vegas later this year. And on the flip side of it is, if you ever try to figure this one out, I've done it for you. This is the UNNI, the 5 gigahertz frequencies in the US if you're using them. It gives you all the channels, the rules that apply to you and how you use them. Where they guard band things, where the TDWR radio is, and just a lot of useful information on the wireless side. So anybody wants those, I'll have them afterwards. I can just grab hold of me today, or I'll be around all day tomorrow. I can give you one. Could be pretty useful for you. Yeah, I did this because it's something that I always have to look up. I can never remember, and so it'll give you all the frequencies and all the latest channels, and whether it's 20 megahertz, 40 megahertz, 80 megahertz, or 160 megahertz, and AC will never fly in the WISP environment. Outdoors, you can only get one 160 megahertz channel if you want to use AC at 160. This one actually drops into the DFS band. So it's great in theory, it'll work great indoors, but outdoors you're going to pick up tons of interference there. So it's a useful cheat sheet for you with all the frequencies on. Anyway, thank you very much. Anybody got any questions? Too much information there. I hope it was useful. The thing is, scripting is very, very useful. It can be very useful, and if you go through it carefully, it's not too difficult to do. Sorry, yes?
The charger and the battery you had, those are just regular diodes that supply the power?
Yeah, those normally just use Schottky diodes or 5 amp ones. That's all you use. And the way we mount them, because you don't have a printed circuit board, we're saying just get 2 of these little terminal strips. We can screw down the things to put the diodes between them. And all it's doing is the voltage is going to the 2. Only the one with the higher voltage will be the one that's actually there. One thing about it is when you go into MikroTik, if you're doing something on this, and you look at the voltages, you'll find the voltages wrong by a bit. What happens is there is if we're getting 27.6 volts out of the power supply, we're going to get about 27 volts here. You're going to lose about 0.6 volts across the diode. Inside of the MikroTik routers, they got diodes as well. And so you're going to read about 0.6 volts or so less. So you're not going to see, by the time it gets out to one of these ports, it's going to be 26.4 or a little bit less than that, depending on what diodes are being used. So don't think there's something wrong when you do system health and then you see the voltage is not what you're putting in. It's what's coming out of the router. Any other questions?